if cos of theta is 3/8 and theta is not in quadrant 1, find sine of theta and tan of theta. Again, this is trigonometry. What we're going to do lots and lots of times is draw a triangle, and we're going to try and draw that triangle in the right position. So I'm going to draw all 4 quadrants here, and I need to draw a triangle, but according to my cast rule, where is it going to be? Well, they tell me that cos of theta is positive 3/8. So according to the cast rule, I would know, well, it can't be in quadrant 2 and quadrant 3, because that's where cos is negative. So it's either going to be in quadrant 1 or quadrant 4, but the question tells me that it's not in quadrant 1, so I can draw a triangle or an angle that ends in quadrant 4. We always go back to our nearest x-axis, so we can label our reference angle. So first of all, lots of times in these questions, you can draw a triangle, but we're going to want to make sure we draw the triangle in the right quadrant, and we always draw it back to the nearest x-axis so that we can label our reference angle. If we label our reference angle, that allows us to label sides. Because cos of theta is adjacent over hypotenuse, I can now look at my reference angle and say, I know this side would have to be 3, this side would have to be 8. Because adjacent over hypotenuse would give me 3/8. And you use a squared plus b squared equals c squared. You can label the other side. And I said you were going to get really good at mental math with a squared plus b squared equals c squared. So try to solve it in your head and write down the value. I'll put up the answer in a second. Did you get the square root of 55? Again, this is what you're doing in your head. A squared plus b squared equals c squared. You know that the hypotenuse is 8, so the c squared will be 64. You know one of the sides is 3, so 3 squared will be 9. You're asking yourself, what would go there to make 64? Well, in this case, you'd have to subtract the 9 on the other side. That would give you 55. 55 then would be b squared, so b would have to be the square root of 55. And once you've drawn your triangle, you can now go to your reference angle and say, well, I can figure out sine because sine is opposite over hypotenuse, and because it's in quadrant 4, sine would have to be negative. And I can figure out tan, because tan is the opposite side over the adjacent side, and because it's in quadrant 4, it would have to be negative. Very typical question for trigonometry. Figuring out what quadrant you're talking about, drawing the triangle with your reference angle, labeling what you know, and then you can figure out all the other stuff, right? If we could use grade 10 math, we could find the reference angle. Then you could find the actual angle. And a whole bunch of stuff just by drawing the triangle. Question number 2. Most students initially get this one wrong because we've just finished the unit circle. We just labeled a whole bunch of points, right? We labeled a whole bunch of points on your unit circle. You look at all the points on your unit circle, and this one isn't on there. So the gut reaction would be to say, no, it's not on the unit circle, I just checked mine. But we have to realize that the unit circle is the whole circle, which has an infinite amount of points. We only are able to do some of them without our calculator, but there's a whole bunch on here that we don't know. So now this becomes a possibility. Is this on the circle or not? So how do we tell? We will either use the equation of the circle, any point that's on the unit circle, this is the equation of the unit circle, or this is the same as the big idea, right? Because your x-coordinate is cos and your y-coordinate is sine. So with this in mind, we have to decide, okay, if this is on the unit circle, and I take my x coordinate, and I square it, and then I take my y coordinate, and I square it, and if I add those two together, if it equals 1, it's on the circle. If it equals something else, it's not on the circle. So we have to determine, what is this equal to? Well, if I square root of 3 times square root of 3, that'll be 3. 3 times 3 would be 9. Square root of 6 times square root of 6 would be 6, and 3 times 3 would be 9. If I add these together, I get 9 over 9, which is equal to 1. So I can say, yes, it is on the unit circle. If I got any number other than 1, then I would say no, it is not on the unit circle. So here I'm using the equation for the unit circle to determine whether it's on the unit circle or not. If negative 12 over 13 comma y is a point on the unit circle in quadrant 3, find y. Again, we'll use the same strategy that we'll use in in question 1. We'll draw a picture. We know whatever this is in quadrant 3. I can make a triangle back to my nearest x-axis and label my reference angle. I can label sides on this triangle if I also think about the big idea that my x-coordinate is always cos, my y-coordinate is always sine. So because we're told this is a point on the unit circle, we know that cos of theta is negative 12 over 13. And since cos is adjacent over hypotenuse, I could label, I know this length is 12, this length is 13. And then a squared plus b squared equals c squared. You'll find out this length is 5. And if I know that length is 5, I can tell that sine of theta will be negative 5 over 13. Again, I'm thinking about my task rule as well. I'm in quadrant 3. Cos and sine have to be negative in quadrant 3. Now, this question didn't ask us, we haven't actually answered the question yet, right? Because if you read it carefully, it says, find y. I've done that, but I haven't actually stated it, right? I need to finally say y equals negative 5 over 13. Because my y-coordinate is sine of theta. So now I have solved it. So test is on Monday. On Tuesday, we're going to be continuing to work through this worksheet. Wednesday, we're going to do our quiz. Have a wonderful weekend. Yes. Yeah, I'll just might have grabbed 2. Yes. So those of you that need that's there and the one that's missing? That's the one with the name